we have a polynomial function described by this equation, f of x equals ax squared plus bx plus c. And you've worked with polynomials before, so you should know they produce parabolas. In this case, it's graphed on the xy coordinate plane, and you can see it's one of those upside down parabolas, right? It tops out, I don't know, somewhere around here, and then shoots back down again. And I want to know when f of x equals 0, in other words, y equals 0. Remember, y is typically represented as f of x. When y equals 0, which of the following descriptions best matches the solution set for x? So let's talk about that phrase right there, the solution set for x. What that means is, when y equals 0, right here, what is the solution set for x? In other words, what x values are true? Well, here they are. There's one, there's one. Those dots are the solution set for x. So which one of these descriptions down here matches them? Well, two real solutions that are not distinct. That sounds kind of close. Let's put a question mark near that. I can cross out this one, positive and negative, because look, those x values are both positive. So we cross those out, and they're not negative. Can cross that one out. Two distinct positive real solutions. Yeah, that kind of sounds like what I'm talking about. And there's nothing imaginary going on in this graph. You don't have a real and an imaginary solution. Now, all of the things I'm crossing out, one of these may be your answer depending on the style of question you're looking at. So be careful in how you read it. But I want to focus on this word distinct right here, right? What does not distinct mean? Not distinct means the same thing. And distinct means different things. So, I don't know, identical twins are not a great example because there are two bodies. But Siamese twins are not distinct, right? They share a body. Whereas distinct people can, go home to separate places. So we've got not distinct would mean. Here, let me give you an example of what not distinct looks like. And I'm going to cut out the metaphors and let's just use a real example. Here's a graph that has not distinct solutions for x. In other words, just a single solution. It's I guess, two real solutions that overlap on the same spot. So we are looking at, for ours, two distinct positive real solutions.